be sure to go back and highlight the important words for square. What is that? Parallelogram and what? Four right angles and four congruent sides. If you don't have that in your definition, it's just going to be bad for you the whole time. The next one is a what? Trapezoid. Trapezoid. Okay. Now, can a trapezoid be a parallelogram? Can it be? No, it cannot be, right? So what's your first word going to be then? A quadrilateral. So it is a quadrilateral with. Now, some books differ in exactly what a trapezoid is. Some books say a trapezoid is a quadrilateral with one pair of parallel sides. And then other books say with exactly one pair of parallel sides. Why do you think that there is a big difference between those two definitions? John? Right, exactly. You nailed it. Okay. Such as this. Does this have one pair of parallel sides? Yes, so that would be called a trapezoid. Does this have one pair of parallel sides? Yes. It just doesn't have it exactly one pair, but does it have one pair? Yeah, so both of those could technically be called a trapezoid. But that's just not cool, because then the properties of a trapezoid overlap with the properties of a parallelogram, and I don't think it's cool. I don't like it. So I would say that you need to include the word exactly on there. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. So what are the key words? Quadrilateral, and then what? Exactly, and then one pair of parallel sides. All of that is pretty important. So what's the one division of a trapezoid? An isosceles trapezoid. Isosceles. Isosceles trapezoid. Okay. Now, an isosceles trapezoid has to be what first? A trapezoid. Yeah. Could it be a parallelogram? Yes or no? An isosceles trapezoid, could it be a parallelogram? No, it can't be, because it's in a different bracket. Here's A, here's all the parallelograms, and then B, here's all the trapezoids. It can't be a parallelogram. So a trapezoid is a quadrilateral, or you would actually be better off calling it a trapezoid. So an isosceles trapezoid is a trapezoid with the, how about we say this, with congruent non-parallel sides. What in the world does that mean? Okay, well, let's look at it. Let's say that I have a good old-fashioned trapezoid. This is usually the picture of a trapezoid. What makes a trapezoid a trapezoid? One pair of parallel sides, right? So, you guys help me out. You got side 1, 2, 3, and 4. Which sides are the parallel sides? 1 and 3. So what does that make 2 and 4? The what? Non-parallel. So you're either parallel or you're non-parallel. Does that make sense? Okay. So an isosceles trapezoid is a trapezoid first, but then it also, so it's got the parallel sides, and then what's special about the not parallel sides? They are what? Congruent. The other vision of a trapezoid may look something like this. Now, does it look like on this one that this could be an isosceles trapezoid? No, it couldn't be. Why not? Yeah, because they're not congruent. Now, here's the really strange thing, and I'll go ahead and show you this, and then later on it'll make sense. This is not the reason why it's called that, but if you can kind of think of it this way, do you see how that is like an isosceles triangle? Yeah, yeah, yeah. Okay. If I were to like chop off the bottom of this thing, going across there, then these little pieces right here are going to be congruent, and these are also going to be parallel. So if you can think that an isosceles trapezoid is also just part of an isosceles triangle, then you're going to be fine. I think. We'll see. But there you have that. So there's isosceles trapezoid. Uh-oh, I got to skip a line. How do I do it? Shift, return. How do I go backwards to get a C? Shift, tab. There we go. So now what's the next division? Kites. K-I-T-E. Holy night. This is a really, really, really stinky definition. What is it first? A quadrilateral. With exactly well, how about this? Instead of saying exactly, you can say with. You can leave exactly in there. It doesn't matter. With two pair of adjacent sides congruent, but the pair are not congruent to each other. It is probably the one shape that is easiest to point out in picture form, but it is the most difficult to write a definition for. That's the special thing about a kite. Okay, so first you want to call it a quadrilateral, and then actually the rest of the definition is as important as that word quadrilateral. So there you go. Let's look at what a kite would be. A kite is exactly as you think it would be. It looks like a kite. Now, 1, 2, 3, and number 4 side. Which sides are adjacent? Anybody want to give me a pair? Which ones are adjacent? 1 and 2. What else are adjacent? 4 and 3. What else are adjacent? 1 and 4. What's not adjacent? 1 and 3 or 2 and 4. So this is what it says. It says two pair of adjacent sides congruent. So 1 and 2 are congruent to each other, but the pair are not congruent to each other. So that means 3 and 4 are congruent to each other, but they can't be congruent to 1 and 2. See how that works? Okay. This is the reason why you have to throw that in. Let's say sides 1, 2, 3, and 4 again. This is why you have to put this part right here. Let's say that I've got 1 and 2 congruent to each other. Is that good enough so far? And then I've got 3 and 4 congruent to each other. Is that good enough so far? Okay. But now what do you notice? All the sides are congruent. So what does that throw it into? Being a what? What is this shape right here? A rhombus. Can a rhombus ever be a kite? No, it can't. So that's why you have to throw that phrase in there. But they are not congruent to each other. And there are the sketches, I am pretty sure, for all of those words.